Alright, test-inspired warm-ups. Again, made while I was making the key for the test, and I hit some of these. I'm like, ooh, that's an interesting problem. Maybe we should see that ahead of time. And so I wrote one that was similar-ish to, yeah, I'm frozen again. Similar-ish to the test. So these are definitely good problems to know. Alright, the first one. Find the equation of the line tangent to the curve. So when I see that, I should immediately think I need a point and a slope. I've got a point, so that's easy. The slope, of course, I'll get from the derivative. So let's take a derivative, we'll plug in the point, that'll give us the slope, and then some of you went ahead and wrote y minus, well, you know it's going to be 1/2 times slope, or equals slope times x minus 1/2. Like that's our normal setup. If you work the problem, you know something weird happens on this one. But this is normally how we set up the problem. Take a derivative to find the slope, and the slope goes there, and then we're good. So let's take a derivative. 2y times y prime minus y prime equals 1 minus 6x. So y prime times 2y minus 1 equals 1 minus 6x. So y prime is 1 minus 6x over 2y minus 1. Then we can evaluate that at our point. We can just do at 1/2 comma 1/2. So 1 minus 6 times 1/2 over 2 times 1/2 minus 1. Let's see, 1 minus 3 is -2. And then 1 minus 1 is 0. And that's where you guys are like, wait a minute, something's not right, because I know I can't divide by 0. So thankfully, I don't think anyone just put equals 0 there. That wouldn't be good. But y prime is undefined. So the derivative is undefined, which means the slope is undefined. But that doesn't mean the problem is undefined. There is a line with a undefined slope. And then you guys kind of hashed it out on which one it was. But an undefined slope is a vertical line, which means it's x equals something. And if we want to go through the point, it better be x equals 1/2. So that's a weird problem. Maybe we should go back and throw that thing out, because it's not like normal. Because it's undefined, we get x equals 1/2. What if the slope was 0? What kind of line would that look like first? What would that look like? So show me with your arms and hands. Yes. So what would the equation for a line that looks like this be? Y equals. Now that one would actually still work over here, because the 0 times all that would mess it up, or would wipe it out. So if the slope is 0, you could still use this format. It would just maybe look kind of funny. It'd be better if you just recognize that if slope is 0, that's a y equals line. If slope is undefined, that's an x equals line. So that was kind of a special case. Something weird happened. So I don't remember seeing one quite like that. So I wanted to make sure you saw that. Number 2. Find the second derivative. Remember, there's no shortcuts to the second derivative. You just got to find the first one and then take another derivative. So derivative of cosine is negative sine of y times y prime, right? Chain rule, equals 2. I'm going to solve for y prime before taking another derivative, because if I do it right here, I'm going to need the product rule. So it can be done. It's just I can avoid that though if I'll divide by sine of y, or negative sine of y. All right, now I've got choices. You may not even realize you have choices. What rule will you need if you want to take the derivative of this guy? Quotient rule, which is fine. We know the quotient rule. But if you know some trig stuff, we could switch this around and avoid the quotient rule. Because what's sine in the bottom the same thing as? Who's his reciprocal partner? Which one is it? Cosecant. So if you want to take the derivative here, that's fine, but you would need the quotient rule. If you want the derivative here, you have to know the derivative of cosecant. So I guess if you know the derivative of cosecant, I think this would be easier. If you forgot the derivative of cosecant, well then I guess go back and do the quotient rule with sine. You should land at the same spot. I'm going to go with cosecant because I know the derivative of cosecant. I have to think about it for a minute because I don't really. I know the derivative of secant is secant tangent. So that means the derivative of cosecant is negative cosecant cotangent. And don't forget the chain rule, dy dx. Okay, am I ready to plug things in yet? Oh, not really. What do I need to do? We have done this before. Before I can plug in my point, I need to find, or I need to plug in dy dx. So the second derivative is 2 cosecant of y cotangent of y times negative cosecant of y. Which now I can clean up a little bit to be negative 4 cosecant squared of y times cotangent of y. And I'm still not done because it said at the point, so I've got to plug in this point. So negative 4 cosecant of pi over 3 squared times cotangent of pi over 3. Is that a safe stop?
Yes.
It is. It is a safe stop. So that's kind of nice that you can leave trig things as safe stops as long as you finish plugging things in. Now, on the test, this one is a multiple choice question. So I'm just going to force you into finding the cosecants and cotangents. So, hey, show your work and you'll get partial credit, even on a multiple choice test. Let's see, cosecant is the flip of sine. So that would be 2 over root 3. Cotangent of pi over 3 is x over y. So that's 1 over square root of 3, or square root of 3 over 3, either one. So that's a better safe stop. Well, I shouldn't say better. There's not really a better safe stop. That's also a safe stop. But that still wouldn't be the multiple choice answer. Let's see, 4 times 4 over 3 times root 3 over 3. That's 16 root 3 over 9, and I think I forgot my negative in there somewhere. So, safe stop, multiple choice. That's a yucky problem, which is why I wanted you to see it before you saw it on the test. Number 3. This one's back to, I think, a little bit easier. Derivative of natural log is 1 over the argument times the derivative of the argument. So here's the important part, or the part that we forget. The derivative of y is y prime. Derivative of 3x squared is 6x. And just 4 on the other side. So I'm solving for y prime, but there's only one of them, so this shouldn't be too bad to get y prime by itself. I'm going to multiply both sides by y minus 3x squared to get that over. And what would I do next? Look at what would I do next to get y prime by itself. trying to get y by itself, and I've got y minus 6x. So ignore the junk on the other side. Let's just add the 6x. That is a safe stop, and it didn't tell me to plug in anything, so yeah, we're good with that. While I'm thinking about it and recording, let me do a very brief test outline. Put it on the board so I would remember it. There's 14 multiple choice questions. By the way, it's all no calculator. On the AP test, they allot you 2 minutes per multiple choice question that's without calculator. So people were concerned about timing on this test, so I'm going to try to show you why it's okay. The timing is going to work out. One free response that's, I think, 3 parts. Free response questions, they allot 15 minutes per free response question. And this one's shorter than most of the ones on the test because we don't know enough to do a full-blown big one. So maybe more like 10 minutes, but we'll say 15. And so all that together makes 43. Obviously we have, I think, 50 minutes on a test day. So you'll have a few more minutes than AP would grant you. So at least 7, but really a few more than that. So it'll be paced like an AP test is paced, roughly. But you have a few extra minutes in there.
How many points are each question?
Now that I haven't figured out yet. Because
3 each, yeah.
3 each, so that makes 42.
That sounds good. And that part is like 18.
I think there's like 3 sub-points to that. Times 5 is 15. I'm only at 57 there, gentlemen. So
43 points after.
I think that's good.
And we get iHeart count too.
Plus bonus.
plus a bonus, so that's 57. So minimum would be 43 plus your 5 bonus.
I think that's good.
So you'd make a 48 just by showing up and putting your name on the paper. That'd be great. Except no, we'll not do it that way.
Why? I want 4 points.
4 points. Now we're getting more reasonable here.
Let's just settle it for.
Yeah, I think we're good on 4.
And maybe we make those 6, 18. We're still only at 74 there, so
That's good.
that sounds great, doesn't it? That means you'd make a 26 for showing up and putting your name on the paper.
That's valid.
You're like, yeah. I mean, your name's worth 26 points, right? Like, all right, let's shut the video